So let's try to look at organic chemistry. So if you're interested in joining my online tuition, you can WhatsApp me on this number. So the question is saying the structures of 6 organic compounds are shown below. So organic compounds are identified. You can identify organic compounds by looking at the functional group. So we can see that here we have a functional group here, we also have a functional group here, as well as a double bonds or single bond, being saturated or unsaturated hydrocarbons. So the first question is asking us to define what the term hydrocarbon means. Define what is meant by the term hydrocarbons. So as you can see, this word here contains 2 terms. We have hydro, which is coming from hydrogen, and carbon, which is just coming from the carbon atom. So when we talk of hydrocarbons, here we focus much on the alkanes. Okay, we focus much on the alkanes as well as the alkenes, because we know to say that these are the these are the organic compounds that contain hydrogen and carbon only. So if we were to identify from what we have here, we can see that A is an hydrocarbon, C is an hydrocarbon, F is an hydrocarbon, as well as F is an hydrocarbon, because these compounds, they just contain hydrogen and carbon only. So we can say hydrocarbons, these are saturated or unsaturated. These are saturated or unsaturated. Saturated or unsaturated organic compounds. Organic compounds made up of carbon, let me say made up of hydrogen and carbon atoms only, and carbon atoms only. So in short, they just made up of hydrogen and carbon atoms only. So that is what it means, or that is what it meant by the term hydrocarbons. So in terms of when you want to understand which ones here are saturated and which ones here are unsaturated. So saturated hydrocarbons, they are alkanes, and unsaturated hydrocarbons, they are alkenes. This is because of a double bond, and alkanes are saturated because every bond on the carbon are surrounded by the hydrogen atom. Then identify 2 of the compounds that are members of the same homologous series but are not isomers. So you have to understand what isomers are. So isomers are just compounds that have same molecular formula but different structure formula. For example, they can have 4 carbon atoms, and they can also have, let's say, 8 or 10 hydrogen atoms. But in terms of the way you're going to do the structure, you're going to be different. For example, an example which I can give here of isomers, if you look at this one, if we count the number of carbons, we can say 1, 2, 3, 4. Remember, it's a single bond, so here we are supposed to have an H. If you count here, how many carbons? We have 1, 2, 3, 4. Then it is surrounded by hydrogens. So we can say that these are isomers of each other because they are having same number of carbon atoms and same number of hydrogen atoms. So these are isomers. Now the question is saying but not isomers, so we can eliminate these 2. So what we are going to choose here, we are going to choose A and F. The reason why I'm choosing A and F, this is because of a double bond. So these are alkenes. So you can say A and F. Why are we not choosing others? Like for example, why are we not choosing D and B? This is because D is representing an alcohol. An alcohol, they have an hydroxyl group. Then B is representing an acid because it has a cool group here, or carboxyl group. Then for question B, which two compounds are isomers of each other. So I've identified to say C and E, they are isomers of each other. This is because they have 4 carbons, then the number of hydrogen atoms, they are equal to this one here, but in terms of the way they have drawn this one, it is different from this one. So the structure is different, but the molecular formula is the same. So that is C and E. Then F can be prepared from D. Give a chemical equation for the reaction. So we are preparing F from D. So what are we having on F? So on F we are having an alkene because of a double bond. Then on D we are having an alcohol. So for you to form an alkene from an alcohol has to lose this hydroxyl group here. So if you're losing an hydroxyl group, that one we say it as dehydration, because what is going to be formed at the end is water. So that is the dehydration reaction. So that is what they are looking for. But remember, what compound is this one? Since this compound here is having 2 carbon atoms, meaning to say this one is going to be ethanol. Ethanol. It's an alcohol. So what are we going to have? Since that one is ethanol, so in terms of the way we are going to write it, we can say that is CH3, CH2, then we put hydroxyl. So since this one is dehydration, we are going to say, once it undergoes dehydration, what are we going to have? We are going to have an ethene here. Okay, an ethene with also a CH2, then plus water at the end, since this one is dehydration reaction. So now there are some conditions which are very, very important for you to know here. One is that aluminium hydroxide, it has to be present on this one here. So number one, aluminium hydroxide, it has to be present. Apart from aluminium hydroxide, concentrated sulfuric acid, it has to be present. So that is concentrated sulfuric acid, it has to be present. Then also heat, or we can say temperature. So this temperature, it has to be 170 degrees Celsius. So these are the conditions which are very, very important to write or to know when you're carrying out dehydration. So this is dehydration reaction otherwise, because at the end we are giving out water, or water is lost in the process, and what we are yielding here is an alkene. So writing the general formula, we can say we have an alcohol, okay, and this an alcohol is going to undergo dehydration. Then what are we going to put? What are we going to produce? We are going to produce an alkene, then plus water. Then the favorable conditions, we know to say that we have concentrated sulfuric acid. Okay, concentrated sulfuric acid. Then apart from concentrated sulfuric acid, also note to say aluminium hydroxide, it has to be present. Then heat, it has to be present, or temperature. And this one, it has to be 170 degrees Celsius. So these are the things that you have to know on this part here. Then the last question is asking us to explain what is meant by the term non-biodegradable. So there is a term biodegradable and non-biodegradable. Biodegradable substances are substances that can decay, okay, or that can decay naturally by microorganisms. For non-biodegradable, these are substances, organic substances that cannot be naturally decayed by microorganisms, like plastics, tires, as well as containers or plastic containers, all those things, because there are no living organisms or microorganisms that can cause decay to those ones. So we can say these are organic materials that cannot be decayed, or that cannot decay naturally. by microorganisms. Microorganisms. Then from there we are done. So thank you very much for watching. Remember to subscribe for more videos.